Today we are going to see a review of the concept of the transfer function as we derived it last time and as we as we are supposed to be entering it into Simulink in MATLAB. Mainly in this case, we're going to do it in MATLAB. So if you look at the screen in here, on the left-hand side, we have the system in question, and we have said that to find the differential equation, we apply Kirchhoff's laws, and here it is. The voltage drops for the R element, the C element, and the L are over here. And then we say that I is dq dt, and we put the equation in terms of the charge, which brings us to a second order differential equation as is expressed over here. We wrote some steps on how to go about finding the transfer function now, and that is in here we have the Laplace transform. For differentiation, the operator is s is d dt of any function, and for the integration is 1 over s. If you have double differentiation, the operator is s squared, and so by doing that, dq dt is s times q of s, and d squared q dt squared is s squared times q of s. In this case, we are interested on the transfer function as it relates to the voltage across the capacitor in relationship to the voltage input. This ratio is called the transfer function. So the voltage of the C element across the C is 1 over C times the integral of I dt. And if you operate this if you operate it in here, is the you integrate, you obtain this q of s, so it's 1 over c times q of s, yeah. And then in here the voltage, we replace those in terms of the s variable is this. We factor q of s out, and we have an expression for the voltage p of s and relate to the charge. So if you find that ratio, we come up with this transfer function, and once we have it this way, we are ready to enter it into the Simulink. And what I'm saying, to MATLAB. This is you could say that the transfer function is always the relation or the ratio between an output and an input, or that the output is the transfer function times the input. So if that's the case, we would like to enter it into the MATLAB forming here. We could just reduce this window to the point that we only see the transfer function that we need. There we go. So if you come over here, well, you have this in here. You have a numerator, and then you have a denominator, because the transfer function is always a fraction. So what you're going to say is you enter the numerator is going to be for the C element, we're going to do a 1 farad. So this is 1 over C in here. See, do we have 1 over C? I think so. So we'll just, in this case, do a 1. And the denominator of this is equal in here. You have that L is 1 and C is 1. So this is going to be a 1. like a polynomial we enter. R is 0.5 and C is 1, so this is 0.5. And then we have one more term, this 1 in here. And then we close the parenthesis, the square bracket like this. So once we have defined the numerator and the denominator, we're going to say that g is a transfer function of the numerator and the denominator. And if you do that, the computer will go to the control system toolbox and produce for you the transfer function as you see on the board there. So I think you can see it very clearly, but you could actually change the font and make it bigger. But my point is that now we have the transfer function. Now you see here's something very important that we need to consider. If you put it in this form, that the voltage output is the transfer function times the input, then it follows that I could give a step input to this transfer function and get the voltage answer, see? So in here you're gonna say that this is step input and give the name of the transfer function like this. And if you do this, then you're going to get the response in the time domain. And this is one of the major contributions that Laplace did, is to be able to analyze the output of a system by knowing the transfer function. Okay, so in here, I think it would be helpful is to remember how you enter this into the MATLAB and how do you could do other things in here because the computer knows what the transfer function is. In fact, if you type G, it's going to give you the transfer function, see? Now, I would say that it is easier at times to define this variable as a transfer function variable and then treat the fraction as if it would be an algebraic expression. And you will be able to do the transfer function also. So let me explain what I'm trying to say. In other words, we're done with this because we got the transfer function and it's in the workspace. I did the step input, but I could try different things, like for example the impulse response. I say impulse of the transfer function, and then the computer is going to go and calculate. See, it did it over here. See, so this is the very basics of control system analysis, because now with the transfer function you have the power to know what the system is going to do in relationship to a specific input. Okay, granted that this example that I gave you is a simple example, and we need to do some other things to be able to obtain this transfer function. Okay, so what I wanted to say is that, let's say if we clear this workspace, MATLAB doesn't know anything about what I did up there, just plain blank. And then I am going to say here that the S variable is going to be, I think it's called SYS of to define as a system variable.